Hey guys, welcome to the next lesson on energy efficiency. In today's lesson, we're going to talk about what energy efficiency is, with the lesson objective being to understand the idea of energy efficiency and how to calculate it. So energy efficiency is referred to how efficient or how effective an object is at transforming, so changing energy from one type to another. The less energy which is wasted means the more energy efficient that device or object is. So for example, if a device is 75% energy efficient, it'll be more efficient than a device which is only 32.5% efficient. So this 75% efficient device means that a quarter or 25% of the energy will not be transformed into the energy that we want, and 25% will be lost elsewhere. It's calculated by the formula energy efficiency in percentage equals the energy output in joules, capital J, divided by energy input, also in joules. And you multiply that whole number, this number here, the answer, by 100 to get it into a percentage. So, for example, a rubber band has 10 joules of elastic energy when it's stretched. When that elastic band is then released, the energy is transformed into 6 joules of kinetic energy. What's the energy efficiency? So we need to identify the output. The output is what we finish with, what we are left with at the end. And the input is how much we started with. So usually the output is going to be a smaller number than the input in most cases. That is how you can identify that you're doing the sum correctly. So you have the smaller number, which is the energy output, or 6 on top, and the energy input, which is 10, large number on the bottom. You divide 6 by 10, you have 0.6, and then you multiply that number by 100, which will give you 60% energy efficiency for this rubber band. If we're doing a slightly more complicated problem, this one here, there's an object has energy efficiency of 42%. So you're told the energy efficiency. Then you're also told the energy input, and you're asked to calculate the energy output for this particular object. So to do that, what you do is you write the formula out. Energy efficiency is equal to 42%. We don't know what the output is, so that's an X there. And we do know what the input is, which is 1200 joules multiplied by 100 equals 42%. So now we have X over 1200 times 100 equals 42%. So what we need to do is we need to find energy output and put it by itself. So to do that, we do what was done last to this number here. So the multiply by 100, we can get rid of that by dividing by 100. So if we divide by 100 over here, that will cancel out the 100 here. But what we do from one side of the equation, we need to do to the other. So we also need to divide 42 by 100, 42% by 100. So now we have the energy output divided by 1200, that's still remaining. There's no times 100 here because we've gotten rid of it, equals 0.42. 42% is the same as 0.42 as a decimal. Now, we need to get energy output by itself. So, what was done last to energy input, energy output, it was divide by 1200. So if we multiply 1200, we will be able to get energy output by itself. So multiply there. What we do one side, we do to the other of the equation. So it becomes 0.42 times 1200, which equals 504. So the energy output is 504 joules. And we can see that the energy output of 504 is smaller than the energy input of 1200. So that makes sense. The output will usually be smaller than the input. These are the ideas we covered today. Power is the amount of energy used in a given period of time. It's measured in watts, which is with a capital W, or you can write the whole word, doesn't matter. Terms that you need to be familiar with, and energy in joules, time in seconds when you're calculating the questions. And these are the questions I'd like you to complete before the class. So if an object uses a large amount of power, what does this tell you about its energy consumption? Now you need to use the formula in your explanation. So what happens if an object uses a large amount of power. What does that tell you about its energy and its time being used? Calculate the power for the following 3, and then this question here, calculate the energy output of a car which is working at 33% efficiency and has an energy input of 1500 joules. Thanks.